Hello students, we'll start with the new topic from today's session of our paper 2 content, that is chapter number 2, logic gates and Boolean algebra. This chapter will have the 15 marks of weightage to the board exam point of view. Likewise, a previous topic of number system, you'll find this topic is also very easy to understand, and I'm very sure you'll get the maximum marks in the board exam once you learn this topic thoroughly. We shall begin with the sub-content of this topic, that is types of logic gates. In this session, you will learn brief idea about meaning of logic gate, variety of logical operations or logic types. Types of logic means positive logic and negative logic. Then we shall learn in brief classification of available logic gates as per our syllabus into two groups or categories. First as a different types of basic logic gate, and then we shall learn different types of derived logic gates. We'll try to understand all types of logic gate on various aspects such as their logic symbol, logical operation, truth table, and Boolean equation that indicate operation performed by these logic gates one by one, briefly in the session very soon. Very first, let me know the meaning of logic gates. What are the logic gates? Basically, logic gates are an electronic circuit which has one or more number of inputs with a single output. Every logic gate you'll find once we start to learn, they contain at least one or may have the more than one, two or more number of inputs, but output is always only one. You'll find the inputs and outputs that available with this gate, the inputs we applied, output that gate will use are having only two states, either low or high. That means it contains only two states or two levels. That two states or two levels which represent the input and output that processed by these logic gates are called as binary information. That means logic gates can process the signals in the form of two states only or two levels, such as we can call them as true or false, high or low, or logic 1 or logic 0. 1 stand for the high, 0 stand for logic low. Now logic gates are used in every digital electronic circuit. In all types of digital circuit, you'll find there is use of logic gate. That means logic gates are the basic elements of all digital electronic circuits. Let me know the concept of two different types of logics used in the logic circuit. That is positive logic and a negative logic. Meaning of positive logic, as I told, voltage levels are used to represent logic 1 and logic 0. If the high voltage, H means high voltage, used to represent logic 1 and the low voltage means L value is used to represent logic 0, then it is to be known as a positive logic. Here is the example with the help of this table. Variety of logical combinations are used for logic 1 and 0 in positive logic states. So the first can be as plus 5 volt to indicate 1, 0 volt to indicate logic 0, or plus 7 for 1, plus 2 for 0. Or you may have been here use of 0 volt to represent logic 1 and minus 5 volt to represent logic 0. If you observe this table, what do you find? Here, voltage level used to represent 1 is more positive than the voltage level used to represent logic 0. Exactly opposite of this, there can be a negative logic also. In negative logic, the H means high voltage is used to represent logic 0, whereas L stand for low voltage used to represent logic 1. Here is an example. Plus 5 volt for indication of 0 logic. At the same time, 0 volt can be used to represent logic 1, or plus 7 for logic 0 and plus 2 volt for logic 1, or 0 volt for logic 0 and minus 5 volt for logic 1. What do you find here? By this table, voltage level used to represent logic 0 is more positive than the voltage level used to represent logic 1. Hence, it is negation or inversion, hence called as negative logic. That of the previous what you have been done, a positive. Now we'll see some important terms that will be useful henceforth for a continuously content of our paper 2 syllabus. That is logic as a first term. Logic is basically a logical operation performed by the given logic gate. You can define the logic with the help of a statement in words. What type of operation is prescribed or performed in the given logic gate? That is called as logic of given logic gate or logic of given logic circuit containing more number of gates. Second term is the Boolean equation, also called as logical equation, after name of scientist George Boole, who invent a technique that to correlate logical operation with the mathematics. So here is a sort of mathematical equation by which we can understand logical operation, or we can represent logical operation. That equation is called as the Boolean equation. Then we'll have one more term that you'll find always in the content of paper 2 syllabus, that is logic symbol, or simply called as a symbol. Pictorially or pictorial diagram that used to represent a logic gate or logical operation. That diagram is called as a symbol of logic gate. Then one more term is here, that is truth table, in short TT. Truth table stands a table that includes the combination of all inputs corresponding output. That means a table shows an entries of the input for the gate or logic circuit and corresponding output. In precisely, it's mean a table used to show all possible combinations of inputs corresponding true output. That table actually explains the working or operation of a logic gate or a logic circuit. So very first, let me know what are different types of logic gates available in the digital electronics. Logic gates available are broadly classified into two categories or two groups, namely basic gates and derived logic gates. Basic gates are NOT, also called inverter, and OR are three types, and by combination of this there is a invention of one more type of category that is called as derived logic gates, which includes the combination of basic gates such as NAND gate, NOR gate, exclusive OR, also called as XOR, EXOR or XOR, and opposite of XOR there is a XNOR also. We shall learn one by one all of them with all respect in brief, starting with the first type of logic gate as a NOT gate. In case of a NOT gate, you'll find it has only one input with a single output. Logic used in the NOT gate or NOT operation is the output. Suppose Y is the output and A can be as input. The output A, output Y will be high when the input A is low, that means 0, or vice versa. Basically, it is a basic gate. NOT gate is a basic gate. It performs a logical operation, that is a NOT or inversion. We can define the logic used in the NOT gate or inverter with the help of a statement. Output is a high or a 1 when input is a 0 or low, or vice versa. That means output is the inverse of the input. Output is the inverse. If it is 0, will comes 1. If it is 1, will comes 0. Right? Now we can represent mathematically equation for the logic operation NOT, that is called as Boolean equation. Y is equals to A bar. You can read A bar as also complement of A. Complement of A means inversion of A. Therefore, this gate is also called as an inverter. Symbol for this. A is the input. See a triangle with the at vertex bubble. A is the input, Y is the output. We can describe the operation thoroughly by use of a truth table. A as an input and Y as output. TT stand for abbreviation for truth table. Output Y is what? Complement of an input A or A bar. So as per statement, if input 0, output becomes 1. If input is 1, output with inversion becomes as a 0. That brings operation of NOT gate. We'll go for second type of basic gate, OR gate. It has two or more number of input. OR gate can have either two, at least two, or more number of inputs with obviously only one output as second type of basic gate. The logical operation that can be performed by the OR gate we can define with the help of statement as the output is a true, also called as a high. That means logic level 1 or binary 1 if any one input or both the inputs or all inputs are high. In case of two input OR gate, you can define with a simple way as statement output is high if any one or both inputs are high. In case of more than two input type of OR gate, you can define statement as output is high if any one or more or all inputs are at logic high condition. That means output goes high if at least one input is at logic high or one level. Boolean equation that represent the OR operation is given by this form. Y is equals to A plus means OR operation. You can't read A plus B. You must have read as Y equals to A or B, where plus represent the logical OR operation. The symbol A and B are input, Y is the output. See the curve attached with the two inputs, then two curve meet at a common point, one more wire attached to get the output. So here the symbol A and B are input, Y is the output as a usual symbol to represent the logic gate or with the two input. In case of more than two, you can add A, B, C as input, Y as output. If there are four inputs, you can add A, B, C, D as input, Y as output. Here is an example for symbol of two input OR gate. You can extend it for the three input, four input as you need. See the truth table now for the OR gate having two inputs A and B. As two inputs, possible number of combinations can be as a 4. 2 raised to 2 will comes 4. First both input are 0 0 and last both can be as 1 1. 4 possible combinations of inputs. Corresponding output here is listed in the truth table. A and B input, Y as output. As per statement, Y goes 1 if either of input or both inputs are 1 1. That means for 0 0 A and B, Y is 0. If A is 0, B is 1, Y goes 1. If A is 1, B is 0, till Y becomes as a 1. When A and B both are 1 1, also output Y will goes for the logic 1 or high. Then third type of logic gate here is AND gate. Likewise OR gate, AND gate also have either two or more number of inputs with only one or single output. It is also another third one basic logic gate. Now the logic used that can be performed by the AND gate, we can list out, we can define with the help of statement as output is high or 1 only when, or you may say if and only if both inputs are high. In case of two input of AND gate, logical statement can be as output is high, that is 1 only when both the inputs are high or 1. In general, for an AND gate having more than two inputs, 3, 4, 5 and so on, the statement becomes as output is high if and only if all inputs are high. That is for general statement for the AND gate having more number of inputs. So Boolean equation for the AND gate can be here as Y equals to A dot B dot represent AND gate. You must read the statement for equation as Y equals to A and B, right? Then the symbol here, half circle with the vertical line, attach the two input A and B at the center of circle, curve, one more wire attached to get the output Y. So A and B can be input, Y as output. For more number of input, you can add the line C, D and so on as input. Y remains single as output as a symbol for AND gate. Then see here, truth table for two input AND gate as per statement, output goes 1 only when both inputs are 1 1. So for A and B 0 0, output 0. For 0 1, output 0. For 1 0, output 0. Only for A and B as 1 1. A is 1, B is 1. Then only output equals to 1. Is this clear? Let me review as a summary all three basic gates at a glance. AND gate, OR gate and NOT gate. Symbol of two input AND gate, symbol of two input OR gate, symbol of NOT gate. And then the truth table for two input AND gate. Only for last combination of A and B, both input 1 1, output goes 1. Whereas truth table for two input OR gate, output goes 1 if any one of input or both inputs are 1 1. And for NOT gate, output is the inversion of input. If input 0, output 1. If input 1, output goes 0. Just brief summary of three basic gate that we have been learned of still. Now we shall start for next gate. Actually the fourth one, that is the NOT gate. NOR gate is the derived logic gate. It is obtained with the combination of OR followed by NOT operation. First the OR and then inversion. That means a logic gate obtained with combination of OR gate followed by NOT operation is to be called as a NOR gate as derived logic gate. Statement for the NOR gate is exactly opposite that of statement of OR gate. Output will be 1 if the both inputs are at 0. In case of more than two input, output will be high, means 1 if all inputs are 0. Equation for the two input NOR gate, y is equals to A or B complement, or complement of A or B is the correct reading for the statement for two input NOR gate. You can't read as y equals to A plus B bar. No, it is y equals to A or B over all complement or complements of A or B. Symbol here like a OR gate, just bubble is to be added here. Bubble to be added on the output terminal. Now let's see the truth table for two input OR gate. A and B are the input, Y is the output. Just reverse the last column, interchange 1 and 0. For 0 0 it was 0 in the OR gate, it is now here 1. For rest of all three combinations in OR gate, we had there 1 as output, but here with inversion 0 as output, means only for the first case low inputs output is high, both inputs are low, output is high. Whereas if either of input high or both input high, output remains for 0 as a truth table for two input OR gate. Then the fifth type of logic gate here as NAND gate is also derived logic gate obtained with combination of two gates, AND gate followed by NOT will give two input NAND gate. So this is a gate which has an AND gate followed by the NOT operation. Logic performed by the NAND can be just inversion of logic of AND operation. So statement for two input NAND gate will be as the output is high if one of the input or all input are at 0. Let's see here. In case of two input NAND gate, output is 1 if any one or both input are 0. In general, for more than 2 input, 3 input, 4 input, 5 input type of AND gate, statement shall be as the output is high if any one input, more number of input or all inputs are low. Is that clear? That means equation becomes here as just negation of AND operation. Boolean equation for the NAND gate will be as y equals to A and B complement, or you can read as complement of A and B. Symbol, just you have to add a bubble in the output of over the output line. You have to add the bubble only at the output that result as a symbol of NAND in the AND gate symbol. Then a truth table for two input NAND gate, just invert the last column of AND operation. For 0 0 0 1 1 0 first three combination, you'll find both input or at least one input is 1, so output goes high. Only for both input are high, output becomes as a 0 as a truth table. You can extend truth table and symbol for more than 2 inputs. You just add the lines as a 3, 4 and so on, A, B, C, D, E and so on, and make the table one more input. Remember here, only for last column, sorry, last row, when the all inputs are high, that time output 0. Rest of all, either of one input or many inputs are at 0. Therefore, output becomes as a 1. Then, next type of derived logic gate, sixth one. Exclusive OR gate, also called as XOR gate. We'll define here with the help of symbol of XOR gate. Exclusive OR gate has 2 input or more than 2 input with the single output like of all previous logic gates. See here, its output will be high if A is high or B is high, but not both high. Extension for the OR operation. Only when one of the input is high, output goes high, not for the both high like of OR, that exclude the condition of OR, hence to be called as exclusive OR gate. It exclude the last condition of inclusive or basic OR gate, right? Then you can define, that means what here? Output is high if both inputs are different, not same, 0, 0 or 1, 1, right? Equation for this will be as, Boolean equation as y equals to A x or B. A x or B. If we simplify equation, it shows that A and B bar or A bar and B, and with this equation you can draw the diagram. We'll see in the next session about how we can construct a diagram of a 2 input XOR gate by using basic logic gates, right? Then the symbol for 2 input XOR gate. It has 2 inputs A and B. Just add the cur at input of OR gate. Cur as a part of X. So exclusive OR gate. Remaining part of OR gate remains as it is there. Let's see here a truth table for 2 input XOR gate. As per statement of 2 input XOR gate, output goes 1 if either of input is a 0 or any one of input is 1, but not both input 1, 1. So here first input condition 0, 0, both input are same, so output goes 0. 0, 1, 1, 0, inputs are different, output goes 1. For the input A and B 1, 1, both are same, output 0. It is like of OR gate for 0, 0, 0, 0, 1, output is 1, 1, 0, output is 1. Excluding last condition of OR, it was there for 1, 1. In case of OR gate, output goes 1. But here it is 0. It excludes the last condition. Hence, it is called as exclusive OR gate. Then see here, inversion of exclusive OR gate will brings us the logic gate as exclusive NOR gate, which shows here negation of the operation of OR gate. XNOR gate, likewise XOR gate, can have more inputs. It can be of just inversion of output. That means you have to show the bubble on the output here. It may have 2 or more number of inputs with single output. Just you have to place the bubble in the symbol of XOR. It will give the XNOR operation. Let's see the logic here. Logic of XNOR, output is high if input A and B are same, means 0, 0 and 1, 1. Both are high, both are low, then only output goes high. Boolean equation for XNOR gate, y equals to A XOR B complement. That means complement of A XOR B. But equation for A XOR B is what? A and B bar or A and B bar over all complement will be as resultant equation of XNOR gate. We shall construct in our next session equation from this equation a logic diagram for XNOR gate by using basic logic gate. Now see here a symbol of XOR gate, only you have to add a bubble on the output line. Bubble indicate that inversion of XOR means XNOR operation. Truth table for XNOR gate with the 2 inputs can be as A and B input y as an output. Output goes high if both input are same 0 0 and 1 1. So for 0 0 output high, 1 1 output 1. But if a and b are different, output will not be 1, it will be 0. That means for 0 0 output 1, for 0 1 output 0, for 1 0 output 0, for 1 1 output goes 1. Just if you repeat the truth table of XOR gate with the last column with inversion at place of 1 0 at place of 0 1, that brings a truth table for XNOR gate. Is this clear? At a glance, let me have the summary of all derived logic gates. Mainly there are three derived logic gates as a main gates: NAND, NOR, and XOR. Symbol of NAND gate like a AND, just bubble on output line. Symbol of NOR gate, A and B out inputs, just bubble placed on the output line. Symbol of XOR, A and B input, Y as output. If you want XNOR, add the bubble on output line. Then truth table for two input NAND gate. For 0 0 output 0, 0 1 output 1, 1 0 output 1, for 1 1 0. That means output goes 0 only when both inputs are 1 1 as a logic of one more way of indicating logic of NAND gate. Then in case of two input NOR gate, for A and B input, here is a truth table for the output Y. Only for 0 0 input, output goes 1 as another way of describing the logic of NOR gate. For 0 1 1 0 and 1 1 input, output remains as a 0. Whereas for XOR gate, output becomes as a 0 if both inputs are same, or output goes 1 for different inputs. For 0 1 and 1 0 input, output becomes as a 1. It excludes the condition of OR. When 1 1 output goes 1, it is here 0, hence called as exclusive OR gate. Dear students, you are now familiar with different types of basic as well as derived logic gates. You could have the practice of all these logic gates with their symbol, logical statement, equations, and truth table will be useful for our next session. Remember, all logic gates with their symbol, equations, and truth table throughout the content of paper 2 will going to be used again and again. In our next session, we shall learn universal logic gates and De Morgan's theorems, where you will learn the concept of universal building blocks of digital electronics, and there are basic theorems used in the interchanging of logical operations by name of scientists. They are called as De Morgan's theorem. In our next session, that is of universal